chapter.
Yeah. Okay, I don't know if that's important.
We're all here.
Sweet. So going over the questions.
No, I guess we can just pop over and do that for a second.
So the difference between the central limit theorem and the law of large numbers is the central limit theorem is kind of talking about the shape of it, like as the sample size increases, the more normal it becomes.
Yeah.
And
well, they said that if the sample size is large enough, or if there's a normal distribution, or if the parent population is normal, then it's normal.
And how does the normal distribution differ from what we were talking about last time? Like last week, I'm trying to like reach in my head.
I'll be honest, I don't know.
Because it's like the same bell-shaped curve, right? But the last one, I can't even remember what the term
Maybe
was.
they are the same, but
yeah.
Like it was
I'm just trying to like separate my head, like.
Or maybe it's the same thing, but we're just going like more into depth about distributions.
Yeah, I'm trying to. I don't know.
I have no idea. Is that you, right?
Yeah.
Dang, I would have known it's a live stream.
Yeah, mine's
No, she's probably still asleep. Let's be honest.
The law of large numbers is just saying like the more people that you get in a sample.
Yeah, the law of large numbers is basically what I just explained, right? That as long as the population is large enough, then the curve is going to start looking more and more normal, right?
Yeah, well, I think that's the central limit theorem. Is the shape of it?
Yeah, that one's the shape.
Because I think that's going to be a test question for sure. Because they mentioned it like 4 times. Like, be able to tell the difference between the central limit theorem and law.
So what was the difference then?
The large numbers. It just states as the sample size increases, the standard deviation of the sample will get smaller.
And it gets closer to the mean. So like if you're flipping a coin, like I might do like if we do,
okay, so I'm mixing it up. Okay.
Yeah, if we do 10, then I might get all heads. But then if you do 300, you're probably going to get an equal number of heads and tails. So.
And so what's that called again?
Law of large numbers.
Oh, the law of large numbers.
Yeah.
If you more and more that you get, the closer it's going to be to the mean. That's what it says.
Yes.
So the standard deviation obviously decreases because that's exactly what it is. It's the distance.
But is that saying like in theory you could know what the mean is going to be? Because like how could you know the mean without flipping it 500 times? And how do you know that you've ever hit like what the
I think it's an exact science.
Interesting. So okay.
So yeah, that's the law of large numbers. And the other one was whatever that. What was the other one called again? There's law of
central.
And that's if the population is large enough, and if the parent population or whatever is normal.
Yeah, central limit theorem. So the difference is one's talking about the shape and the other's talking about accuracy.
Okay, cool. Shape, accuracy. Got it. I'm having a hard time pulling up.
Did your sample mean appear to be unusual?
Mine was.
All right, unusual?
Well, maybe not unusual, but it was far off in the middle.
Like it wasn't a bell curve.
So was it?
I guess, okay, so the shape, we just put it on that shape, so I mean, obviously it's still normal, but mine, like, what was yours?
Mine was 44,040.
Mine was 51,200.
What did you get?
I'll be honest. I just watched the videos.
Okay.
Dang it, you were going to compare it to mine.
Yeah, so if it's 44, okay, so mine's 44,000. It's just kind of like to the left. But
mine's
it's still
like
on
where
the plot.
It's really skinny. So
like,
I guess.
So remind me again, is this like based on the exact same numbers, or they actually get your own numbers?
You just get random numbers.
Yeah, so it wouldn't matter. You obviously, guys, we get different things because you got different numbers.
But the question is it usual or unusual?
Is mine
And
still
why?
usual?
I would think so. I don't know because it just or well is unusual like just a lower probability number or is unusual like it's not
So
on the
it's
graph?
usual or
But I don't know if it's
unusual
possible
what?
to not to be on the graph because.
Because there's probably no numbers that would make it like that.
But how could that contain all? Well, I guess that could contain all 142,000 possible combinations. You know, does it talk about that in the chapter?
Actually, it could. You could get it off the
So-
graph if you got them all like the high numbers.
Really? So then that would be
If you
unusual.
got 522, like if you got all 22s, because those are all above, they're off the graph.
So then ours would be usual.
So mine's
would
usual.
not
Then,
help.
yeah.
I Google it. And that doesn't make any sense. We can therefore identify unusual values by determining if they lie outside these limits. Maximum usual value equals that weird u plus 2 to that. Like,
Yeah, so mine's
identify
definitely
unusual
usual
by
then.
determining if they lie outside these limits. Okay.
Yeah.
Makes sense.
Cool.
Okay. In practice, you only get to see the means. The means are slightly different. Some are even. Yeah. So I mean, I just got different means every time.
Yeah.
I don't know if we're supposed to have somebody else go.
So
pick random
compared to
means.
like 3 or 4 people, but I mean, I assume it's
Well,
probably just our group.
in the videos, he just used like a randomizer.
Number
Is
generator.
that what you guys use?
Yeah.
Yeah, I saw the video after. I was just like randomly picking it up. Like, you're like,
This is super random.
yeah. Okay, so what is the shape of the distribution of sample means for all such samples?
Normal.
For yeah, but why is it normal?
Because it said normally distributed. I don't know.
Oh yeah, because like if the scores are normally distributed, then the shape is going to be normal.
Yeah.
No, that goes back to that thing I was talking about, right? If the parent population means is normal, then it's going to be normal.
Yeah. And that's actually the next question.
Yeah.
How do you know? And it's just because the parent
Bam.
population.
Help a little bit, guys.
What is the mean of the sample distribution of sample mean scores for all such samples?
I know
Uh,
it's so confusing.
What is the sampling distribution of sample mean scores for all such samples?
It's
uh,
super- so it's
but it's
basically the
529.
mean, right? And then you go over square root. I watched the video.
Oh, that's the standard.
That's for the
deviation.
mean of the standard. Yeah, this one's just the mean,
What
which
is
actually just gives it to us. It's kind of weird.
what is the U thing called?
I can't remember what that was
That's
called.
the mean.
It's like it's like sigma or like.
Oh, I don't know the name.
Okay, because I know there's mu. I just want to start understanding those in case they ever stop dropping the little parenthesis things.
And they're
but-
just like, yeah, you were supposed to.
But yeah, okay. So they just gave us what the normally distributed mean was, which is 529, which is also the Greek U,
Yeah.
Sure.
and then standard deviation of the distribution. So
So I saw that. I checked the answer and it's like 35 something.
Mhm.
How the heck do you get that though? I tried doing the mean divided by the square root of
When I
the
is this the last question?
yeah. So I took. Let's see if I still have it. Basically, you take 113, which is Q, or like
Yeah.
the upside down Q, which I forget
the
what its
weird
name
looking
is.
thing.
Yeah. Wait, what is that though? That's the standard deviation.
Yeah.
No.
That's
Is
the
it?
standard deviation. Yeah.
Okay, so that little symbol is the standard deviation. So you take
Q.
that, and then it's
You-
over
over
the square
square
root
root.
of 10
Uh-huh.
because your sample size was
Square
10.
root of 10. Okay.
Because that's how many you took, right?
Yeah, because you take the standard
Standard
Deviation divided
over
by the square root
of the number of samples.
yeah, and that's
Okay.
what gives you 35.
Do ya? Do ya? So she only asked us to record, like, going over this stuff, right? She doesn't ask us to record answering the questions on the quiz.
I don't know. It just says record the meeting.
I'm so confused. I feel like a lot of it's ambiguous. Oh, wow.
Doesn't make a difference. I don't think anybody watches the whole video.
I don't think anybody does. Are we supposed to watch it?
No. But I just think it's just proof that you actually did it.
Yeah.
No, when I first saw she gives a 50, I was like, are you kidding me?
Yeah, I mean, I guess if the video doesn't exist, then it makes sense. But
Of course she gave us
Yeah.
a 50. We said we did it, and there's no proof.
Yeah, just kind of dumb because I doubt she even watched it.
It's okay. I said that I only did that.
I feel fine about what I've said so far.
Sorry, Bruce. No, this can be perfect. Okay.
Yeah.
Are we done? Should we do the?
Yeah, we should do
quiz
the
now?
quiz.
We just got to make sure that next time we meet, we're definitely prepared because I feel like it's going to be easy.
Yeah,
If I would have been prepared, I don't think it would have been quite as bad with like 3 collective lines actually done. I didn't do anything. It was
last
bad.
week
It was bad.
I did it all and I read it like twice.
Really?
Yeah, I
It's
still
just that
was
hard
like,
to.
it's not hard. It's just a lot of information.
Yeah. Completed. Okay, are we all on the quiz now?
Yeah.
Heck yeah, I actively participated.
Let's see if it'll show me the photos this time. That'd be cool.
While you are required to work together on this quiz.
Oh yeah, sorry about that.
You did use a link.
forgot I
Oh,
was doing
sorry.
something. I don't remember what. But
When
when you asked that to send me
Oh,
the picture,
yeah.
I was in Utah,
Alright.
but I don't remember what it was.
No, it's all good.
When you're taking a sample size of n, so 5, what is the shape of the distribution on its histogram when the parent population is right skewed? So,
When you're taking a sample size of any,
wouldn't it be right skewed? Skewed right? It's basically the same as the parent population. Isn't that what we were learning? Something like
Okay, so we have, because that's going back to like that little applet thing,
Sure.
I think.
And there's a link to the applet,
Is there?
normal probability applet.
Oh,
yeah.
so we can use it then.
Yeah.
I do not have permission to leave this page.
Oh, that's
My mom says I can.
Okay, so what they're saying is population. I don't even know how you would do that though. Would that be the area?
Oh, wait. This isn't the right little applet.
What?
Look at this thing.
Wait, let me see.
That's
That's
not
what
the
it
thing.
popped up with. I don't know.
Yeah, that's not the one that we were using in the homework or whatever.
I don't know what's going on. But I'm
Okay.
pretty sure it would be the same. What? Wait. Well, remember what it said? So I know for sure it won't be normal because it says that the parent population is normal. Therefore, the whatever it's asking would be normal, right? But since it's not normal, I'm assuming that it'd be the same.
I think it'd be skewed right as
Yeah,
well.
that's what I was thinking. Because I know for sure it wouldn't be normal. And it wouldn't make sense to be skewed left.
Well, because it doesn't make sense that it'd be normal because you have such a small sample size.
Well,
Because like
and
the
they
larger
also
the sample
said
size, the more
the
normal.
larger
it
the
becomes.
sample size, the closer to normal it is. And then also, if the parent population is normal, then it will be normal. But neither of those things were correct, so obviously.
Yeah, when you take a sample size.
What is the shape of the distribution mean histogram in the parent population right skewed?
So would that be
Well,
normal?
it's closer to normal.
Because 30 is the limit, right? Or like for this
Yeah,
class
it is
anyway.
above 30.
If it's above
Well,
30, it's probably
Above 30,
normal.
then closer.
I feel good about that. All right. When you're taking a sample size of n, what is the shape of the distribution? Parent population normal. We
Yeah,
know if it's
I
normal, then
hope
it's
we're doing
normal,
this right?
right?
Yeah,
I think so.
you never know.
When taking a sample size of 100, what is the shape of the distribution? Parent population normally just normal.
Yeah, because it doesn't make a difference in the
If
sample
the parent
size.
population is normal, it's normal. That's what I was told in the video. When would the distribution means be normally distributed? Oh, wait, okay. So data are drawn from a population that is normally distributed and a sample size is small. No.
No, that's true, isn't it?
Well,
Well,
Oh,
yeah,
yes, because
yeah,
there's no-
that is
yes,
true,
that is true,
actually.
'cause
So we're marking all that
doesn't
true.
matter if it's-
Data drawn from a population that is normal. If it's drawn from a population that's normal, then
So I think it's the second one as well. Than the last
first, second, and data drawn from a population right skewed and the sample size is large. Yeah, I believe you are correct.
So we'll figure out our. I mean, it seems like they're testing the same thing. So if this marks like each individual wrong or whatever, we'll know
yeah,
one. Yeah.
which of our assumptions are
which of the
wrong.
following gives the best explanation of the central limit theorem? So the central limit theorem was the one you were talking about when it gets closer to the mean, right?
No, that's the other one.
No.
What is? Yeah, the central.
Oh, the rule of large numbers.
Yeah,
Yes.
the rule of large
And the
numbers.
central limit theorem is exactly what I just explained. If the parent population is normally distributed, then sample
I think it's the
will
last
follow
one.
a normal distribution. The sample size of the
Yeah,
largest
because it's
sample
talking
mean
about
will be
sample
close to the
size,
population.
not population.
Wait,
Yeah.
but I think it was both.
The parent population for which the data drawn is normally distributed. The sample mean will follow.
I think
a
it
normal
was
distribution.
talking about the parent population and the sample size. Am I
The
right?
sample size is large. The shape of the distribution.
Because both of those are correct.
No, because this doesn't use the word shape, which is significant because they emphasize that in the video. But like, if a parent population from the data is drawn is normally distributed, the sample mean will follow a normal distribution. I mean,
We can
if
always
the
go
sample
back, I
size
guess.
is large, the shape of the distribution sample means will be approximately normal. I think it's that, but
You think if the sample size is large, the shape of the central will be close to the population.
but
right?
parent population though, that sounds familiar as well.
That's what I was saying.
So, but
Can you
what
click
is
more than
what is
one?
the parent population? That's just saying the entire, or like where the data is coming from. Or
Yeah, exactly.
The sample mean.
If
X
the
will follow.
sample size is large, the shape of the distribution of sample means will be approximately. I think it's either the last one or the second from the last one. It's kind of hard to know.
I think it's the last one.
All right, we'll go with it, and if it's wrong,
Well,
change it.
it should be the last one because of the emphasis on shape, and then,
Emphasis on shape. Okay. All right, so
because I think it is, and it's about the increasing.
use the following to answer the
The-
next 4 questions. Okay, with the population mean of this and population standard deviation of that. Suppose sample size of that is drawn from this population. What is the mean of distribution of the sample mean? So
the
that's what
mean
we were
is
talking
the mean
about,
is
right?
10, right?
What is the mean of the sample distribution?
Because it
Of the
says let
distribution
X be
of
random.
Maybe 10. Wait, could you guys explain that to me?
Oh, because it says let X be a random variable with the population mean U equals
So
10.
basically, all you're supposed to know is that
Yeah, that one's called
that
mu.
U is the mean. Is that
Yeah.
what you're saying?
Yeah.
Okay. What's the standard deviation? Okay, so now this is where we're doing the standard deviation over the square root of the sample size, correct?
Yeah, which is just 6, because that's the 60. So it's
So
just
wait.
1.6666.
Okay,
666.
I'm just gonna make sure. So
That's
standard
the
deviation,
devil's number. I don't think it's right.
the sample size of 6, which the square root of 36 is 6, right?
Yeah.
So then it's 6 divided by 6, which is what's giving you the 1.666.
Yeah.
Wait, it's sample size of 6. Where
Is
does it say
it
sample
population
size
or
of
the
6?
standard
It
deviation?
just gives me 1.
So you're supposed to do over the sample
Yeah.
size. The sample size is 36,
Yeah, because you're taking this.
not the standard deviation.
Wait.
Are you
Uh,
dividing it by 10 or
So
by 6?
you're supposed to do it over the sample size?
yeah, because it's the standard deviation over the square root of the sample
Okay,
size.
then it is 1. I was dividing it over 10.
Oh, that's all good. They probably put that in there on purpose to confuse you.
Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the shape of the
Normal.
distribution? Regardless of
Right?
the distribution of the population, if the sample size is large, what would the shape
Yeah,
of
it's
the
just
distribution
being
be?
normal. Because it's just saying over
Let's
30.
see, regardless of the distribution. Isn't that
Uh,
explaining exactly what we're just talking about?
Yeah.
Yeah. Bimodal.
What theorem would justify your response to the last question?
Central-
Law of large numbers.
No.
No. Wait.
It's talking about the shape. So it'd be
Yeah, you're right. It is central limit theorem. because the law of large numbers was talking about the
standard
distance
deviation away.
from the mean. All right.
Are we right?
So I'm like Donkey Kong, guys.
Well, maybe we should look over it.
It's too late. I already did it. Sorry. Wait, you were submitting a quiz? There's a problem with your attempt. What the freak? It says it's already been submitted. What the F is going on? Wait, is this lesson?
We've been doing pretty good with these little quizzes.
Is this lesson 3?
It's less than 6.
Lesson 6.
Yeah, another 100.
Yeah.
I think.
Not bad.
I mean, I suppose I was getting that. It didn't. It was weird. It like loaded